Now for the demo, I'm using an external power supply. It's an 8 amp power supply. The ones that were purchased through the Kickstarter are actually 10 and 15 amps, so they're going to go faster than this one. But the thing I wanted to kind of show is just how the little LED works. There you go. So it turns on at around 5 volts. So before that, you just kind of have to be patient and believe that it's on. Now there's a pretty big discrepancy between what my power supply reads and what this reads, but it does level off once the power starts going down. The important part before doing a weld is making sure that this little meter has hit at least 8.4 to 8.5 volts, but really you want to let it settle. Once it gets down to about 8.8 is when you've got, you know, a decent charge in it. But it's not linear, so the closer you get to 9, the slower it's going to be. So at some point you can just kind of call it quits and say that 8.8 is good enough. You'll want a small screwdriver to adjust the timing pot here. If you turn it counterclockwise, you can turn it down to 0, start with a quarter turn, and then give it a try. Oh, not enough, so we'll give it another quarter turn. And this was actually a little too powerful, so we'll have to go down 1/8 of a turn. But, whoops, there you go, certainly worked. Still blowing through a little bit. Put down a little bit more. Just a smidge. And there you go. So it's hard to see because I can't zoom in really, and there's a lot of reflection. So there's going to be some tweaking to do, and that's kind of, you know, it goes with the kind of timing system we have here. The other thing, last part of the instructions, there's no battery and it's unplugged, power is still on. Fan is still running, it'll slowly deplete the caps. You just kind of let it sit on its own and it's going to take care of it. Play with is the spacing, so the further the spacing, the more power is going to require. But that also means, you know, if you're having trouble, if they're too close together, you might be having trouble with kind of the amount of precision you can have in the timing. So, you know, spacing a bit apart will give you a bit more granularity on the timer. But if they're too far apart, then, you know, you're going to need way too much power, so that's not going to work either. And that was with 0.1 millimeter nickel. 0.15 millimeter nickel is substantially harder to do. So the amount of power you need squares. So we're going to go up a half turn, which is actually pretty close to the max. As you can see, it went through. And we have I'm going to cut myself if I keep doing this, but I can't take it apart, so I'm going to use some pliers. Or actually, you know what? I'm going to put some gloves on. There you go, and we have proper flagging. And now, of course, when you're doing thicker material with longer pulse times, it does mean you need a bit more time between pulses, because obviously you're using more energy, you have to charge it up a bit more. But at the end of the day, you've got a device that does what we set out to do, and I'm really happy with that.